Welcome to Brain Vision.
Hello. So this is a long one. Uh, we using Newton's second law for this. Okay. So the thrust force, the rocket is going up. So the thrust force T is upwards, and then the weight is always down. Okay. So because it's moving upwards, you're gonna have T minus mg equals ma. Okay. So if you isolate A, you're gonna get this. Of course, we know that W equals mg. So you can always say that M equals W over G. So you can substitute this for M, and that was going to lead to that. Okay, so here let's remember that the weight of the rocket is W. So now we can calculate the acceleration based on the formula we saw earlier, and the acceleration is going to be this. This is in feet per second squared. Okay, so now we can calculate the distance traveled by the rocket. Okay, remember that here initial velocity is going to be 0. So we're using Newton's equation. Okay, S equals to ut plus half gt squared. Okay, so just put in everything. You get S1, distance traveled by the rocket, to be 144.9 feet. Okay, so that's S1. We're going to move forward to calculate the final velocity at the end of 1 second. Okay, so at the end of 1 second, the velocity is this. That's at the end of 1 second using v equals u plus at. Okay, now we can calculate the time taken to reach the maximum height. So we're looking for T2, right? So of course initial is 0 always, so V2 is going to be equal to AT2, so T2 is going to be V2 over A. Okay, so oh no, excuse me, at the maximum height, final velocity is rather 0, so this is rather 0, not V1. Okay, because this is V1, right? So we're looking for T2, and that's going to be 9 seconds. Okay, now finally we can answer the questions. So the first one, where we're looking for the maximum height reached, S2 is going to be S1 plus V1 T2 plus half VT squared. Okay, so we have everything, we just substitute, and then we're going to get 1449. Okay, feet. Total time required is going to be T1 plus T2, right? So that's 1 second plus 9 seconds is 10 seconds. Okay. Thank you very much.